In this problem, we are evaluating a function, and we're actually looking at it two different ways. So the first part, part A, wants us to evaluate the k function when the input is 2. So all we're really going to do is substitute 2 in for our variable. So when I write this, k in this instance is not a variable, it's the name of the function. We are inputting 2. So that's just showing what we're inputting, and then I'm going to replace my variable with that input value. And so now when I evaluate, I'm going to get 2 times 2 minus 1, so k evaluated with an input of 2 is equal to 3. So I would enter 3 in that box. Now recall that k, when we do function notation, you can think of function notation as the same thing as the output. Okay, so kind of just have that in your mind. So we are used to seeing functions or equations like y equals 2x minus 1. That's what we're used to seeing. This is the same type of problem, just written in function form. So keeping all of that in mind, when we move on to part B, they're telling us solve now when the function or the output value is 7. So in other words, if this was not in function notation and we were using x and y like what we're accustomed to using, they're saying, okay, y is 7, the output is 7, and you have to figure out what that input is. So when we go back to our function, the output is 7, and we've got to figure out what was the input. So you're just subbing in that value for the kt. So I just solve this equation. Add 1, 8 equals 2t, divide by 2, t equals 4. So when I have an output of 7, that means the input must have been 4.